Hi, and welcome to this talk about how to understand OCL and the differences between OCL and SQL or SQL, and how to change your understanding from SQL to OCL, and how to think about what's going on when you're running an OCL query. I'm basing this on the same model as in previous talks. We have up here in the MDriven designer a small model. We have a few rows of data. We have a person table with 4 people in it, and they are split, you could say, between the adults and the children. You also have a single object in the family class. And these classes are, as in previous talks I've talked about, they are mapped to tables in the SQL Server. Now, what's the basic differences between SQL and the OCL? Well, at its most basic level, it is that if you look down here, you see the traditional output of a SQL query. And that is basically something that looks like an Excel sheet. It's rows and it's columns. And this is important to understand, the SQL Server don't understand the result here. It can't separate them. They are just rows and they are columns. And each row, of course, have columns. But they can come from different objects. And the SQL Server doesn't know where each of these things come from. And that is different from OCL. OCL is object-oriented, which means that it works on complete object almost all the time. You can work with attributes, and you can work with collections of attributes called tuples, which is just a fancy word for something that is held together like a table. And as soon as you convert something to a tuple, you basically lose track of the content. It's just data. It's not an object anymore. Well, or as C# would call it, it's an anonymous type, which means that basically we just constructed this thing right now and we put some data in it. And that is also what the SQL Server outputs. It outputs huge tables of tuples or anonymous types or chunks of attributes. Because as you see here, I do select star from A0 person, that table. I'll just call it person. Skip talking about that part. And what we get here is just a bunch of attributes. If you do the same thing up here, you would do person dot all instances. And we run the evaluation, and you'll get the same result here. This looks very similar, but the big difference is that the framework knows that these are objects of a specific type, whereas these are just rows with data in them. Now, this is both good and sometimes troublesome, because you will find that in OCL it is sometimes difficult to just, get the data. It's always very much about the type. But that actually turns out to be a very small problem when you're working with a user interface, because it's rare that you just want to bunch stuff together like a SQL server does. You usually want to see how things relate and how they are linked to each other. You can follow the link. Now, there are two other things that's important to understand when it comes to SQL, like this query here and this query here. They create the same result, but they have very different ways to get going, how to find data. And in SQL, it's always without a context. You have to provide a context and you have to tell it what to get. Here in OCL, we also provide the context and we say all instances. That's all objects. But that's in OCL, that's an unusual thing. That's only when you're searching for the root or for the context or for something to hold on to. Most things in OCL then just carries on from that thing you have found. And that's a good thing, because in most user interfaces, you just don't go roaming around in the database trying to fetch stuff. You have a root or you have a context. You wish to find something from a specific other object. In SQL, it's always without a context. A single SQL statement doesn't have a context, doesn't have a root, doesn't relate to anything around it. So every call from a user interface to a SQL server, the client has to repeat what it's, you could say, talking about. And that's a main difference in the concept. SQL constructs or texts or queries, they stand on their own. You can just run it and you can bunch things together, but you never get something that's very intelligent out of it. You just get rows with attributes. It's a completely different story with OCL, because here, for example, if we now click on this one, the framework knows that this is not just a row with some attributes. It's actually an object that has attributes, but it also have links to the family here, for example. If you click here, you'll see the Johnson Anderson family object. And this has profound implications for how you write queries and how you handle a lot of things when it comes to constructing user interfaces. Now, leaving SQL aside, to the side for a while, let's have a look at a OCL statement. Let's remove this one. Here you can see that we are without context. And what happens if you ask, is there a context? No. It's red dot and there's no context. If I now paste back the person.allInstances, yes, we have a context, or at least we get something in return. We get a collection of person objects. That means that we can now work on that collection. We can ask for, from the person, a collection is just a bunch of things, a bunch of objects. Let's pick something out of it. Let's pick, you can see over here, let's pick the first name. So we started out with a collection of persons. We pick the first name from each of those objects, and you get a collection of strings. The dot here means for each one of the things in the collection, in this case a person, get the first name. And OCL always works on collections. And it's an easy thing to forget at times, that it's always working on a collection. Then it can be a collection of one, and then it's an object. But you have to differentiate between a collection that can be one in it and a specific object, a specific row if it was a SQL Server. In SQL Server, you would be used to joining things together. For example, here we select everything from the person, and then we will join to, let's say, family. The family has a family ID that should be equal to the person's family ID. Is that correct? No. No, it's called, let's see, A0 family ID and A0 family ID. Still not correct. Let's see here. Yeah, it's called family ID only in person. Let's see there. Oh, there we go. So what happened here now? Well, we joined together for every person. We looked up the family and we got rows, the same amount of rows, and we got the family information. So you could say, wow, that's great. You know, you can just pick whatever you like from each of them. Yeah. How would this look in OCL? Well, you have the person all instances, and if we edit this one, we can navigate to family. So what will we get then? Let's run this. Okay, we don't get the same thing, because in OCL we took for each of the person objects, we navigated to the family, and we get only family objects. And then of course you could say, wow, that's not good. I mean, I want the first name, the last name, and the family. True, but that's not really what OCL is for. OCL is not great at creating reports, which is basically what we have done here in the SQL query. It is much better to create and find complete objects, not objects put together from pieces. So if we want to do what we have done here in SQL, we'll be using a view model instead. A view model is the thing that makes it possible to easily create extractions of data, and where you concentrate a little bit more on extracting attributes out of the objects. That's why we have view models. The things with view models is that they are much more powerful and much easier to navigate and use, and much more precise and more easy to error check than writing SQL. As you noticed, it took me quite a while to get this thing here together. And it's easily to join incorrectly. So this is the thing that we are not going to do. We are not going to work with how to assemble single attributes. If you want to do that, turn to view models.